Hi guys, in this session we're going to be looking at what a gradient is in a straight line. Okay, so to get started, first idea you need to understand is that when you have your Cartesian plane, so you've got y and x, when the line is actually increasing, so what I mean by increasing is when the line actually looks like this, or anything along the lines where it's actually really steep or just steep, but it's all going up. So this is usually what we call positive gradients because it's increasing. All right. Then you have negative gradients. So with negative gradients, what happens is as you go towards the positive side of x, the line is actually decreasing. So this is negative, that's negative. This one here, even though it's slightly going down, it's negative. Yeah, so there you go, another negative gradient there. Okay, so that's the kind of first idea you need to understand. Positive means positive gradient means it's going up. Negative gradient means it's going down. Okay, so how do we actually? All right, guys. So what is a gradient? The way it has many forms. All right. The symbol that we use for gradient is m. So the way we can look at it is gradient can be written as delta y over delta x. Some places they say change in y divided by change in x. In some places you see it as rise over run. And in some places you see y2 minus y1 divided by x2 minus x1. Now, if you're going to carry on with maths at level 2, guys, I'm going to say start using this one because trust me, it just makes a lot more sense when you get to level 2 to use this particular formula for the gradient. So, show you guys a couple of examples and then you can see how it actually works out. So here is a Cartesian plane, and I'm going to say I've got a straight line that's going to look something like this. Oh, maybe not that one. Let's see. So say we've got a straight line going through these 2 points. Now, the way rise over run works is that we actually go, okay, so we start from, using these 2 points, you actually create a right angle triangle. So something like this. All right. And then you literally count how many boxes has it gone on the x-axis. So in this case, it's actually gone two boxes. Can you guys see that? 2 boxes there. This part is called the run. The rise is obviously going up. How much has it risen by? So you've got 1, 2, 3, 4, 5, 6. So for this blue line that I've drawn here, the gradient can be written as rise over run, which is 6 divided by 2, and so the gradient is 3, positive 3. If we have to have a look at another example, and let's say we've got 1 point there and possibly another point there. So with this next example, what we can see is we've got those 2 points. So again, I'm going to create a right angle triangle. Now it doesn't matter which way you do it. So you could have actually done it at the top there as well, like that. That's fine. So in this case, the run is going to be 3 boxes. So that's the run. And then the rise, 2, 3, 4, 5. But the rise, it's actually going down. Because it's going down, we have to actually put it as a negative. Because if it's going up, you put it as positive. If you're going down, you put it as negative. So the gradient is going to be rise over run. Rise is negative 5, and the run is 3. So the gradient for this blue line is going to be negative 5 over 3. All right, let's have a look at another example. All right, guys, so sometimes you will get a situation like this where you're going to get a straight line that looks like this. All right, so what happens in this case? Well, in this case, the gradient is going to equal to 0 because it's not rising up or not is it actually going down. How do we prove it? Well, let's have a look. We know that the equation for rise over gradient is rise over run, right? If we have a look at the run in this case, well, we're starting from here, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Really should have picked a smaller number. 14. But if you look at the rise, there is actually no rise. And because of that, your gradient is going to equal to 0, because 0 divided by any number is 0. So if you get a flat line, flat horizontal line, the gradient is always going to equal to 0. But what about the other case? What I mean by the other case is when you get something like this, where you have a line that actually does this. Now, if you look at in this case, the gradient, well, how much is the rise? 3, 4, 5, 6, 7, 8. So we're going to write m equals rise over run. And m equals, was it 7, was it? No, 8. Yep, it was 8. And there is actually no run. Now, if you try putting a number divided by 0 in your calculator, it comes up with maths error. In this case, we're going to say the gradient is actually undefined. Okay? Because it's not possible for you to actually find a gradient because it's just going up to infinity, or it could be going down to infinity. But when it's a vertical line, we actually say that we can't actually find the gradient. Now guys, in the videos following up, I am going to talk about the gradient using the equation of the gradient. Actually, no, I'm going to show you this session just real quickly. In the next slide, I'm going to show you guys. So guys, remember that I actually said to you earlier that m is equal to y2 minus y1 divided by x2 minus x1. So the reason I showed you guys is this. Sometimes counting boxes will, it's great, but what if you don't have boxes? What if you just were given a couple of points? So say you got these 2 points and you got to figure out what the gradient is. So what you do is you first come up with the points themselves, what the coordinates of the points are. So in this case, I've got point A and then I've got point B. Point A is at 1, 3. Point B is at 8, 7. Okay, so now I'm going to find out the gradient of AB. And the way I can write it is I can write it like this, m of AB. Okay, now obviously I need y2, y1, x2, x1. So what it means is I take the first point, I'm going to call the x value of the first point as x1, the y value of the first point as y1. Now the second point, I'm going to take the x value as the x2 and the y value of the second point as y2. Now it's just a matter of substituting these values, because y2 is 7 minus y1, which is 3, divided by x2, which is 8, minus x1, which is 1. And so if I simplify this, I actually get 4 over 7 as my gradient. Now you can try and do this with the rise over run, because look at this. If you look at the rise, 1, 2, 3, 4, 5, 6, 7. And if you look at the, sorry, what thing was the run? If you look at the rise now, 1, 2, 3, 4. So as you can see, rise is 4, run is 7. But yeah, I mean, I would say guys, just get into the habit of whenever you're using gradient, trying to figure out gradient, use this formula all the time, and it actually helps. It's better than using rise over run. That's all I'm going to say. Okay, that's basically it for this session, folks. Thank you for watching. If there's any questions, pop it in the comments below, and I'll try my best to answer them at some point. Thanks again.